các bạn cứ vào liên tục đó. Cô dạy không được, để cô duyệt hết mấy bạn xíu rồi mình dạy luôn nha. Mình bắt đầu luôn. Có một các bạn nào biết bạn Nguyễn Đăng Khoa không ta? Bạn ấy đăng nhập vô Zoom á, các bạn nhắn giùm bạn ấy là đăng nhập vô MS Team đó các bạn. Nguyễn Đăng Khoa. Bạn nào quen với bạn Nguyễn Đăng Khoa thì nhờ các bạn nhắn với bạn Nguyễn Đăng Khoa, bạn đăng nhập vô Zoom thì không có học được, tại cái này mình sử dụng MS Team mà. Bạn ơi, các bạn check giùm cô coi thử các bạn nhìn thấy bảng chưa các bạn? Các bạn nhìn thấy bảng và các bạn nghe cô nói được chưa? Bạn nào trả lời giùm cô. Check trước khi mình đi vô bài mới. Alo, alo. Thấy cái share slide với các bạn. Tại hiện tại mấy bạn vẫn cứ còn ra vô liên tục, có cô dạy vẫn mất tập trung lắm. Các bạn đợi chút xíu nữa cho mấy bạn vô đủ. Vẫn còn nhiều bạn vô, nếu mà hồi nữa như vậy cô sẽ khóa lại. Các bạn vô học vào đúng giờ xíu. Hiện tại mới có 62 bạn, trăm mười mấy bạn. Các bạn cứ vô biết thôi. Good morning, class. So let me start the new. Before I start with new lesson, so let me review what we already studied in previous class. Okay, so in previous class we studied what model, identification, right? Can you see on the board? Okay. So in the previous we study, các bạn này cứ vô liên tục làm cho cô mất tập trung quá, các bạn cứ request vô lại. Bạn cứ request vô hoài, các bạn nó không có lên đến giờ. Okay, so let me review that. Model identification. So, what is this? In the previous, we tried to define PDQ, Prima model. So, if we want to define the ARIMA model,
is the suitable for your data. So we must define P, D, Q. So first of all, we set like initials model. So for define initial model here, we must define initial of P, D, Q. And after that, we say P, D, Q until we define the model can explain your time series data. That is the main purpose of model identification. So if you want to do that, so you must remember the stationary, right? Stationary, non-stationary, the difference. So differencing is the main purpose of differencing is the link and non-stationary. Transform non-stationary data becomes stationary. So for differencing here, you have like the first or the second is the your data. So until you can find a stationary, but it's not over to. In the previous, we focused on different things. Different thing is just non-seasonal and seasonal. Seasonal. Non-seasonal. So for seasonal, we consider S, ARIMA model, like that. B, D, Q. S that seasonal. For non-seasonal, so just like that. Like the previous lesson, so several students asked me about S here. So let me remind you that S here, that is the length of the seasonal. So for example, if your data is monthly, so S will equal 12. If your data that is quarterly, so S equal 4. So it means, for example, S weekly maybe equals 7. So S here, that is the seasonal length. So it's not always it's 12. Okay. So the question is, so in the previous, you remember different here, that is y will be equals yt minus yt minus is. And that is the for non-seasonal. But for seasonal, you have like that. Yt minus yt minus s. Here represent for the first differences. But what about the second differences? If your data need to do the second differencing, so how we can do that? So let me share with you how we can do with this. So you can look at the slide. I'm gonna share with you in the slide. The slide we call that is the backshift notation. Backshift notation. Okay, what does it mean? It means that support for you to make the difference in the second level. So for the second level, so you can write like that. Okay.
So what is the second level? We want any idea what the second level?
Second level here should be that. First one is actually is different white tea, right? So we can write like that is different white square.
That is
White teas equal to white teas.
so if you look at the backsheet notation in the slide, you can see that you have the backward shift operation B is defined by B equal to Y YT minus. So if in the two periods, so you can see that is the first period, that the second two periods. So you have B and B YT. So will be equal what? B square YT. And that will be equal what? YT minus 2. So it's not it's why let me do step by step for you to see that YT is here, that is the rice, different Y here, that is equal as well. YT is minus YT. Okay. And so from that one, so you can write like that. YT is minus 2 YT is minus 1 plus with YT minus 2. So you may ask me, so how can I draw from plus 1 to plus 1? Right. Right, everyone. So let me show you that. So if you look at this, is BYT. So we have a formula like that. Let me clean it and make that is how we can make the different thing in the second level. This is really so much.
understand about like the second level. So let me do with like B plus B YT equal to YT minus 1. So, one thing about that one, I should write it for you. Let me start with this. I just think the way how I explain that for you easy. YT will be equal with YT minus 1. T plus 1. T minus 1. Okay, that is the first difference. So YT here, we have that is we have one black sheep, that is a given. That's, and so that is we substitute in here that the back sheep. The back sheep have YTs minus what? You substitute in here you have B YT minus 1. BYT. So that is will be 1 minus B YTs. Okay? Okay, everyone? So next, that is the second. In the second, you have YTs. U will be equal with Y. The first minus the first, right? So this one will be equal with this. We just approve 1 minus B YTs, right? And that's one we can write that minus 1 minus B Y T minus 1 is it. So we can rewrite that 1 minus B will be YT minus YT minus 1. So that's one will be equal 1 minus B YT. So I can write like that 1 minus B square YT. Right? So let me write that. From here, I can rewrite that is 7 YTs will be equal to YTs minus 2 minus YT minus 2B YTs. Right, everyone, and plus B square YTs. Right. Let's see. Sorry. Here, that is. Right, that is. 1 minus B. YTs. So we can have 1 minus 2a plus b squared by t is this. So if you look at this, so you can see that the way we can find that one, y, the second one. So we can write like that. The second difference. So it should be like this, because that is the general formula. So here in the second, so we can write that is yd yd's is b. Okay. So that's why in the second one, so we can have b is equal 1. Hello everyone, can you hear me well? Hello? Hello, hello. Hello everyone. Hello everyone, can you hear me well? Oh, just let me know. Okay, because study online class, so let me check if you can hear me. Okay, that is support for you to find the second one. This is very general. So, for example, here in the second level, but what about in the 4 level? But actually, in the real, in the practical, so we just start in the second. Okay, then we finish with model identification. So the next step after you can define, let me review that, define PDQ. What we should do? We move to another, that is we estimate. So what we should do in the estimate parameter. So you know that for every model we have YT regression, right? Regression should be like that. C plus 1 YT minus 1 plus Y T Y T minus P, sorry, yes, Q plus 1 ETs plus 1 minus that is Q P minus Q. So after we finish define PDQ right now, the next step we must to estimate the parameter. So we estimate parameter. What is the coefficient of the regression? Okay, we must to estimate it. So how can we estimate? We can use the least square. Least square methods to estimate, but actually that is you do by hand.
right now we have like many software to support for us to can estimate them. If you put the data here, so you can estimate them. So we also can use like the maximize likelihood procedure to estimate. It means that first they also have the initial, so they update that until they can find a suitable until we can find the parameter here can explain for whitings. But they said that for like for select the ARIMA model, we need to many experience. This means we need to practice, we need to do with data and run many times so we get the experiment when that is suitable. So that it needs many like technical skill. So that's why I don't mention, I don't want to focus on like maximize likelihood procedure, but I just want to tell you that we can use like many types for R and estimate that. Excel is also can, but we need to do many steps before we can. I think Excel is not support for that. So I see that in the mini tab for R, they refer to do that. Okay. So let me give you example. Okay. So when you estimate the parameter here, so what we should consider the standard error. We should consider S. We should consider T value. So the parameter just significant different from 0. So we keep that in the model. So for example, here you do the hypothesis testing. So we assume that phi1 equal to 0, and alternative hypothesis is phi1 is different with 0. So if you recheck x0, it means phi1 equal to 0. A different result. For example, here you have the hypothesis equal to 0. Alternative is different with 0. So if you recheck that, so phi1 is different 0, so we keep phi1 here in the model. Okay, if that is not significant, if you do not recheck, so you must eliminate phi1 out of the regression model. You drop down from the model. Okay, so remember that. So let me give you an example. So after we finish the model identification, okay, in the first step, so we have the intensive model, the initial model. So we have the initial model like 101 after we finish the first step, okay, everyone. So that is the tentative. So right now we move to the second step. We have like assume that we have the 100 observation. So we run regression model. So you can have like that. That is C. That is P1. That is how to pronounce that one, everyone? To pronounce this notation, but it's 0.5. Okay. And the standard errors for corresponding with each of them, I find that is 7.02, 0.7, and 0.21. So the next step, I calculate t value. I consider the standard errors already, so the next step, that is p value. So for p value, you take that the standard error, so you divide for p1. That is p1, right, everyone? You get as 1.47. But actually, when you run regression, they also give the output. You can see t value in the output. You don't need to do like calculation like that. You can see in the output, Excel or output of Minitab, and also p value. So in here you calculate t test t value and p value. So p value here, that is 0.14. 0.14 is greater than alpha. So that is p value, that is alpha, right? That is p value greater. P value is 0.1. Greater than 0.05, greater than, that is do not recheck or recheck, everyone. I don't know, here that is do not recheck or recheck. Alpha is 0.25. Should be recheck. Recheck or do not recheck, everyone? Hello, who can let me know that I recheck or do not recheck? Everyone who can let me know? Please. So here is depend on like if how many alpha p value. So for example, alpha
alpha equal to 0.01. It's 99%, but usually it's alpha 0.05. But this should be alpha divided 2, right? Okay, so I left this for you. It rejects. If that is equals 0, rejects, so we keep that. If do not reject, so we drop that out of the model. No one answer my question. Okay. So that is we eliminate V1. So if you look at this, everyone, your model is look like this. Have the model. Plus what? 0.5. So right now, that is the V1, right? We delete that. Eliminate them. So right now, the model, the ARIMA model, the original you have, the ARIMA model like that. 1, 0, 1. 1 here represents for R. Here represents for D, right? The difference. And here that is represent for MA. But right now we drop V1 here, the original that from the auto regression, right? Auto regression. So the model right now become what? 1, 1, 0, 1. We transform that become 0, 0, 1, right? Because we eliminate V1 out of the regression model. So you have the new one. So that is the ARIMA. Will be equal what? MA. MA1 because different thing equals 0. T equal to 0, so it becomes as model. Everyone, any question until now? Do you have any question, everyone? Still okay? Okay, so no question, so I will continue. This step, we already estimate the coefficient, right? Estimate the coefficient. So we fit that. The model is like this. The next step, that is the model check
the model checking, that is what we should check. What we should check in the model checking. We check that in the adequacies. So what are your adequacies? So they define that a model is adequate if the residual left over after fixing the model is a symbol or simply why not. So let me give you example later to demonstrate that is what is the garbage checking. And when we model checking in this step, so we should pay on like AFC and PAFCs of procedure. Remember here that is the procedure, that the errors. So suggest how the model can be improved. So, but if you want to check the adequacies, so we use you remember that test, the post-mental test. But I remember I already introduced to you that is this test, right? Non-alternative containment. So when we use that test, here Q represent for the stars, Q stars. So this we use the chi-square distribution. We use chi-square for distribution. Chi-square. And so what is n? Let me write it down. This is the estimate. So here we have Q stars. N is 2. N minus k is 1, or I can write like this. For n minus k. So RK, that is residual autocorrelation at log k. N, that is the number of residual. And number of residual. K, that is the number of last. H, that is the number of time last to be tested. And R, that is the total number of parameter estimate. H minus R, that is the degree of freedom. Okay. So here, when we use that test, so we consider also the p-value. The p-value here that is associated with the Q star. So Q star we can find p-value. If lesser than 0.05, so the model is the inadequacy.
Okay. So if you have the inadequacies here, what should you do? Your model is not enough, not adequacies. So we must do to make a new model, or we can improve the model, or you can modify, should be modified. So when we stop until satisfied model determined, until you get p value here greater than 0.05. Okay. Okay, everyone. Okay, everyone. Các bạn ơi, có cái bạn gì Nguyễn Hoàng Anh Tuấn với bạn Vũ Hoài Anh Thư, bạn ấy bị vô nhầm lớp. Bạn ấy vô nhầm lớp đó, nên là các bạn nào quen hai bạn đó thì nói bạn ấy vô cái lớp vô lại cái lớp time series chứ không phải lớp MCD. Phải bạn người khác vô MCD. Bạn nào biết được hai bạn dùm cô cái nha. Bạn bị vô nhầm. Study the check-in model, the model check-in. So right now we finish with 3 steps, right? The first step we define B, D, Q, and the second step we define the parameter. Parameter is mean the coefficient of the whites. And after that, you check the definition. Okay. Okay, everyone. So the fourth step we must be forecast. So forecast here is we already know, so I don't mention in this procedure. So just mentioning 3 procedures here. Everyone, fortunately, right now we have the software. They can support for us to define like chi-square, Q stars, key value, and the parameter. So we don't need to do by hand. But I will think about that, how we can check your understanding in the final exam. So I should ask you to calculate or another version. I don't know, but let me think about that. Okay, so let's go with example for model checking. So, for example, the significance spike at the seasonal lag suggests an additional component to the chosen model. Significance spike at the small lag suggests increasing non-seasonal
AR or AMA component of the model. So here we have positional latch and positional. Right now we need to use like Pomental test, right? Test for receiver. Check the accuracies here. If not, we must modify or make new until p-value greater than 0.05. In here, I mentioned about AICs, AIC value. So actually here, that is one kind of the parameter we need to calculate by the formula, but actually we have the software help us to do that. So I don't want you to focus on this one. But I'm also putting it here. So for you, when you read the books, you can understand. You know about like AICs. Okay. So any question with like model identification, estimate parameter, and model checking? Any question, everyone? If you don't have the question, so I go with the example. So in example here, that is the cover 3-step over 3-step. So okay, I want you to spend time to read the problem first, and we can do step by step. Everyone, I upload the Excel file in the Blackboard. Can you see it? So that is the data for this example. If possible, so you can download the Excel file and we can practice on that. But unfortunately, Excel just can support for us to get the regression only. But if you can find, if you want to find like autocorrelation function, we must do several steps. So in here, I have the websites that is support for us to make like the ARIMA testing, also the ARIMA procedure, difference identification of estimate. So I copy the link and send it to you. If you refer to your Excel, so you can do this one, or also the Minitab. Because I use the MacBook, so I cannot find the Minitab version support for Mac. So if everyone you will use Windows, so you can download the Minitabs. Here, everyone, I copy the link and I send the chat box. Open it. That is a book for Excel, but I think useful. Everyone, can you see it? See the link? Everyone. Hello. Hello. You hear me? You still hear me? Okay, thank you. So if you look at the website, if you look at the Excel file, so in the ICS Corporation, so I already run the question. And in another sheet, I also put another data is for you to practice. Okay, and you finished to read the example. So let me go to explain that. So right now they want to build a ARIMA model, right? So what the data I just given you in the Excel file, so we can draw the plots like this. So look at this plot. So who can let me know that is the stationary and non-stationary? Please respond me, because that is online class just only me because it's so boring. Everyone, that is stationary and non-stationary. Look at the sharing slide. Or you can, if you want it, so you can practice to run that, to draw the plot, so you can see that. Yeah, that's here. That is the stationary, is it? So that is the stationary. The stock price vary about the fixed value approximately 250. So if you look at the 250 here, that is the fluctuates around 250. Okay. The next step. So in this example here, I'm showing you like 3 steps. The first, that is the model identifies. The second, that is the estimate parameter, and final, that is the model checking, and final, that is the forecast. So let's see. With the data like that, so I can draw the autocorrelation function. So for autocorrelation function here, you can see psi and deadline to 0 after left 2, 1, 2, right? Just only 1 and 2. If we look at the partial autocorrelation, close to 0 after left 2, here's left 1, here left 2. So that suggests for you what the figure tell you. Everyone? So they suggest you what kind of model? AR or MA model? And the last K equal 1. So if you want to know that is the AR or MA, so we should to back the slide. It's not that. It's the slide I already shared with you. You remember? Like what is the AR? AR drop out and pop up. Die out and pop. Remember? So open that slide, please, so you can see that. if em ấy. So let me quickly review it for you.
So for MA model, here ACF, PACF for ACF, đây là thấp up, then die out. For MA, then die out, then cut up. And for miss, then die out, die out. So if look at this figure, so who can let me know that is the MA, RA, or miss model? Which one? Everyone, please answer my question. Oh, really? You cannot see slide? So let me share. So what was wrong? Let me share. Okay, it's okay right now, right? So my question is, if you look at the autocorrelation here, baseline to 0 after class 2, and here close to 0 after class 2 for partial autocorrelation. So if you look at this, what the model suggests us, which one we should choose?
Everyone who can answer my question? So, can you explain that is kim ngọc? So, can you give me the reason why you choose that is the MA? Phan Thị Kim Ngọc. MA because the model dropped to 0 after second. But you mentioned about the ACF or PACF. So if you look at this, so AR, if you look at model AR, so you can see so here that is the die out after 0. Autocorrelation is die out after 0. And here that is the cutoff after, that is close to 0 after plus 2. So that is should be 2. One is die out, cutoff. Okay. So the last one we can do that is 2, 0, 0. This is D equal to 0, Q equal to 0. So it means we finish in the first step here, we model identifies. We define the model identification. The next we estimate. So we estimate that is the output of the Minitab. We estimate so what we should consider here. We consider the AR2s is 1.7 E value. But I think we should take a break, and after that we can go back with the estimate. So I think I need a little bit break. Okay, everyone, break, and after that we continue. 10 or 15 minutes for break. Okay, so I will back later. Why can this be missed the model of the block diagram? So should check the model. You should check the model, the autocorrelation and partial autocorrelation of MA and AR and mixed model. Okay, everyone. So we continue. So I just give you explanation about the dial and cutoff. Dial is mean 10 to 0 gradually, and the cutoff is mean is 0. So if you look at these figures, so you can see that the first study dial, ACF dial, and TACF cutoff. Okay, Manuel. Hello, Manuel. So that's why I choose the AR. So I also have deadline to 0, right? Here, that is the close is close to 0 after last 2. That is the cutoff. So we move to the next one, that is the estimate parameter after we define the initial number. So for estimate the coefficient, so we can see that x2 here, no, phi2 is not significant. Let us see. T2, T of Arima 2, T of auto regression 2 equal to 1.75 hertz, combined with p value 0.085. So it's like greater than 0.05, right? Everyone that is greater than 0.05 says. Can you see it? So right now in the second step we consider with the S and T value exists. S is how many? So you have S. So you have the coefficient. So actually you take that's 1. You divide for this one, so you get -2.6. For example, you get the T value of AR1 T value. So T value will be equal to 0.1. So you take, let me see, you check the which one divide everyone? Let you take that number, you divide for this number, is how many we can get? -0.3243 divide for 0.246. So that it will be equal to 2.6. Is this everyone happy to check it? Is this everyone? Okay, let me share the link. So here, in the second step, so we define S and T value. Right now, we consider what AR want T value. So I want to check that. You can see here. So who can help me to check the divide? So let me check 0.324. 2.354.0246. Okay, so you take that number minus 0.3243. You divide 0.1246. So that would be equal minus 2.6. That is the T value. So the same for M2. T value you can calculate on this mistake. So after we calculate P value, what we should do? Everyone, who can let me know? Everyone. So it's not significant at 5% level, but significant at is the 10 level, a 10% level. So if we go back with this one, if we go back with this one. So that is 0. P, we just find that T value here and P value. That is when we check or we accept that. So here we greater than, so do not reject 0.1. We just calculate here the P value to be equal to 1. So greater than 0.05. So if greater than, so we keep that. SD. We do not reject, so we keep that. So right now we stay in this step. So original we have 200, right? 200 right now. So we consider which one should be eliminated, should be deleted. That is P value greater than 1 here. P value here, oh yes, is 0.08. Thank you. 0.085. So eliminate or keep that. Everyone, here we should eliminate or keep that. P value greater than, so that's one should be deleted from the model. Is this? So right now what we have, the new model we have. Okay. Thank you, Kathleen. We keep the 2 as 2% level. So if here that is 0.1, if here is 0.1, so that is should be eliminated. So if lesser than, so we keep that. If greater than, so we delete that. Okay, thank you, Kathleen. Okay, so what we should do next? We can rewrite the model, right? So we keep the model in here. And now we should write the regression. Regression. So write please. C. Here that is two less. I should say we don't need two less. Okay. So pay on the parameter we estimate here, everyone. Pay on the estimate parameter. Pay on the parameter we estimate here. So we can have the model 0, P2. So we have 284. 284.903. And we plus what? The coefficient 1. The coefficient 1. Coefficient 1. Here that is the coefficient 2. And the coefficient 1 is the minus 0.3. 2, 4, 3. You have 3 minus 1. That's what? 0.2. 192 YT plus 2. What do you have? The model. The payon is right. Okay, everyone. So in here, in next slide, okay. So if you look at this slide, so you can see that because right now we have the coefficient here we do it with the step 2. Right now we go with the step 5. That is the model treatment. As a step 3, sorry, model treatment, right? And we finish step 2 right now. Go to step 3. So if you want to check the model here that is the accuracies or not, so you can look at the table here, that is the modified box here and chi-square statistics here. So corresponding with large 12, large 24, large 36, and large 48. So we got the p-value corresponding with that. It's the larger than 5%. If larger than 5%, this means we can conclude that is the deficit, right? But the rest maybe is the lesser than, so they don't steer in the output. So they just the output just show that greater than 5%. So 12, 24, 36, and 48. Okay, so if you look at this again, you can see that degree of freedom. If you look at degree of freedom here, it's just 68. So why degree of freedom here is 68 as 62? We have 65 observation, and in here you have 62 degree of freedom. So you go back with this one. Go back with the step 2. The step 2 degree of freedom that is we define that is 62. The number of time lapse to be tested, that is a 65. 65, everyone. The total number of parameter estimate, the total number right now, here is remember the total number. The total number is mean we check that with AR1, that is 1, AR2, that is 2, so the total should be 3. So degree of freedom will be equal to 65 minus 3 will be equal to 62. Here that is the total. So remember that when you do you solve the problem. So important here that is the total. Everyone, so pay attention on that one. So degree of freedom here that is a 62. So it means we already checked that is the adequacy. So the next step we do the forecast. Because here you see the model I'm already write up regression. Regression, if you want to forecast is 66 because we have 65, so we can use that forecast 66 or 67. So you just forecast several lines. So my question for you, think about that why we need to make like forecast several lines. But actually, in the procedure, so we can start at this step. Check for address is okay. So you have the model here, so you can use for forecast. But they said that we need to forecast for one or several periods into the future can be next. But why we don't need to make more than just one or several? Okay, that is just a question for you to think about that. So in the Excel file, everyone, in the Excel file, I give you the data. So if you have a mini tab, so you can practice to run this data in a mini tab. I also give the second data. So everyone, when I run the regression model by Excel file, I see that the coefficient is not similar with the mini tab output, just a little bit errors. So I think it's still okay. For example, here section we get that is a 2A4, but in here that is a 2A3. Okay, here that is 0. Let me show you. You can open the PDF Excel file so you can see. So let me show you the Excel file. Okay, so if you look at Excel file here, you see here that is 2A4, but Excel file when that is 2A3. Here that is 0.32, 0.31, and 20. I mean here is a little bit different with the mini tab output. And when I take the residual, here S squared, also a little bit different.
So in the mini-tab, so S here will be equal A2A08. But in here I get that is 2783. And in the Excel file, I also give you other data for you to practice. First, if you want to practice that one, you must to draw the class, right? But to see that is the seasonal and then seasonal. If you look at this one, so you can see that is the seasonal and then seasonal everyone. That is seasonal, right? That is seasonal. Okay. So I give you example here for you to practice at home. So if you have like any questions, then we can discuss in the next class. So if you want more example for practice, so I can try and upload in the backward for you. So let me explain in the example. Go backward example. Let me share. Okay. So everyone, go back with example here. After we calculate that, you forget. You can come up with the regression model. So 95% prediction limit approximately y plus with 2s. So y is 2s, and what is s? Y is 2s, everyone. That is the coefficient, right? Not the confidence interval. Is it? So it's y plus with 2 s here y to 2 because that is the limitation. Right? The standard deviation s and standard deviation x. 0.8. Okay. You can get that is 1. That is the confidence interval. confidence interval is working is 95%. So, question I've asked you that why we just do like one or several the focus here. We want to check what the confidence interval. So, example, we use the confidence interval for a period of 66 here. That is 66. So why? Okay, so we can calculate with 67. Okay, everyone. So we just take some of them to check that is the confidence interval. So if you look at this, if you look at this one, so you can see 66 here, 183, because that is the output of the milligraph. So you can see a little bit different if you calculate by hand. So 93.4 here, that is the 391.2 328. So if we find that one, so this is 99%. This means for stationary series. That is the for stationary. If stationary, it should be good thing in the limitation, right? 2 periods. Okay, this is closed. So let me explain that again. Because here that is we have the interval periods. So right now we calculate this one, we compare with this. We compare with that one. So make mistakes. This we compare with this one. That is the longitude. So that is for 66. That is we get from the if that is stationary, so the line here should belong to this period. So we can see that is just the close. So when we compare, we see that is the close, just a little bit different. So we can use the mean or we can use the calculate by hand. Okay. So I give you one example. I want you to practice at home, and we will discuss in next class. Okay, so who emailed for me any question in the previous class? Anyone? Let me see his name. So if you ask me a question, so after class, so I want to answer your question. So you should stay in the method NST. I can answer your question. Bạn Hoàng Dũng. Hoàng Dũng hay gì đó? Hoàng Dũng. Hoàng Dũng em có ở đó không? Cô trả lời câu hỏi của em. Okay, everyone, okay, here. So you asked me the question related with the. That's let me share the screen. You asked me the question related with. Okay. What happened? Okay, you want to ask me the meaning of this figure, right? So actually here they just show you like AR2, the standard 2 class, AR2 corresponding with the coefficient of the regression model. So for example here, Y, that is AR2, they have YTs and C, because I don't know that one, but this one they want to show you 0.5 YT, 1, that's what 0.8. And here that is the MA. This means they want to show you what is the dial and cutoff. Okay. Here show dial, that is cutoff. Here that is the cutoff, is dial, and dial. And alpha 1, alpha 2 just show the coefficient of the regression model. For MA2 also, for beta show the regression, the coefficient of regression model. Just that's just the meaning of this. Dũng? Okay? Okay. If you have any questions, you can continue to send me. Everyone, for the question in the previous, I already uploaded the platform. If you want to discuss more about those questions, so we can discuss right now. So remember, S, like I mentioned, S is not always 12. 12 if that is the monthly. The seasonal is the monthly. But it's the quarterly, so S will be equal to. Okay? S is not fixed.
You just remember that is you can answer the question. Okay, everyone, do you have any question? If you don't have any questions, so we can stop right now. So during you work at home, any questions, so you can send email for me. Or maybe you can message in the MS Team, right? I think so. Because I see some students, they some students they send the message for me. Can you give us free how? So the link, the link I sent it you before. So they have like many techniques to help you to try the lost box test in yourself. You can find it in this website. But I think it's easier for you can download the Minitab if you use like Windows. Minitab is easy. Maybe you can go to lab. Lab also have. Because I use MacBook, so I cannot find any Minitab version. If you have, so you can send it for me. I also want to try with Minitab. Okay. If you don't have any questions, so we end the class. I try to upload more examples for you to practice. Thank you. Bye bye. See you in next class. I hope I can see you in offline class because I think it's online class not fun. But also I'm very thank you and appreciate your answer and contribution. Your contribution in my class. Thank you very much. Okay. See you next class. Bye bye. Linh ơi Linh, cô có nhắn qua Zalo của Linh á, Linh có check Zalo không vậy? Tại vì bữa giờ cô không có thấy Linh Khánh Linh á, cô không thấy Linh trả lời nên là cô muốn Linh check cái Zalo cô có nhắn tin cho Linh là Linh có muốn làm TA á, em check giùm cô nha, check cho xong Linh trả lời giùm cô ha. Cảm ơn các bạn, cảm ơn Linh.